properties. Since dialkyl zinc are highly inflammable, the reactions are carried out in an atmosphere of dry carbon dioxide or nitrogen. Dialkyl zinc are less reactive than Grignard reagents. Reaction with compounds having active hydrogen. Like water, alcohols, phenols, ammonia, primary amines, etc. Similar to Grignard reagent, dialkyl zinc react with compounds having acidic hydrogen atom. That is, hydrogen atom directly bonded to strong electronegative elements like halogens, oxygen, nitrogen, etc. to form alkanes. In this reaction, dialkyl zinc is decomposed into corresponding alkane. CH3 zinc CH3. 2 moles of ethanol gives 2 moles of methane and zinc ethoxide. Diethyl zinc react with ammonia to form ethane and zinc amide, etc. Since there are 2 alkyl groups, 2 moles of compounds having active hydrogen are consumed in these reactions. Reaction with alkyl halides. Dialkyl zinc react with alkyl halides, particularly tertiary alkyl halide, to form higher alkanes. As an example, dimethyl zinc react with tertiary butyl chloride in an atmosphere of dry carbon dioxide or nitrogen to form neopentane. This compound is neopentane, CH3, 4 times carbon. 2,2-dimethyl propane or neopentane. In the case of primary and secondary alkyl halides, the yield is very low. Reaction with carbonyl compounds, that is aldehydes and ketones. Similar to Grignard reagents, dialkyl zinc react with aldehydes and ketones to form an addition product. This reaction is carried out in an atmosphere of carbon dioxide or an inert gas like nitrogen. The addition product on decomposition with the water in acid medium gives an alcohol. In this reaction sequence, formaldehyde gives a primary alcohol. Aldehydes other than formaldehyde gives a secondary alcohol, and ketones gives a tertiary alcohol. For example, dimethyl zinc react with formaldehyde to form an addition product, which on hydrolysis in acid medium gives ethanol, that is a primary alcohol. The side products are zinc hydroxide and methane. Both of these bonds undergo cleavage. If aldehydes other than formaldehyde is used, a secondary alcohol is obtained. As an example, dimethyl zinc react with acetaldehyde to form an addition product. The addition product on hydrolysis in acid medium gives isopropyl alcohol or 2-propanol. It is a secondary alcohol. Dimethyl zinc react with acetone to form an addition product. The addition product can be decomposed into tertiary butyl alcohol by treating with water in presence of dilute acids. It is a tertiary butyl alcohol. It is a tertiary alcohol. Reaction between dialkyl zinc and ketones are very slow. So better results are obtained from aldehydes. If formaldehyde is taken, a primary alcohol is obtained. Aldehydes other than formaldehyde ends with a secondary alcohol. If the formula of a dialkyl zinc is R2Zn, From formaldehyde, RCH2OH is obtained. From acetaldehyde, RCH3CHOH is obtained. Reaction with acid chlorides. Dialkyl zinc gives an addition product with acid chlorides in an atmosphere of dry carbon dioxide or inert gases like nitrogen or argon. The addition product is unstable, spontaneously decomposes into a ketone. Since ketones are considerably less reactive towards dialkyl zinc, further reaction does not take place. Hence, ketones can be conveniently prepared from acid chlorides by reacting with dialkyl zinc. R2Zn react with R-COCl. This reaction is carried out in an atmosphere of dry carbon dioxide or nitrogen, giving R-COZnRCl. It is unstable and decomposes into a ketone R double bond. Since ketones are less reactive towards dialkyl zinc, further reaction normally do not take place. Hence, ketones can be conveniently prepared from acid chlorides. So, compared to Grignard reagent, dialkyl zinc are less reactive. They give reactions similar to Grignard reagent. Nucleophilic substitution reactions with compounds having acidic hydrogen atom, alkyl halide, particularly tertiary alkyl halide, etc. And a nucleophilic addition reaction with carbonyl compounds, acid chloride, etc. Since they are highly inflammable, the reactions are carried out perfectly in the absence of oxygen or air.